Hello. In this section, this is the last section of the course, and we are working with measures of dispersion, how the data spreads out. So the first measure of dispersion is the range. So the range of the data set is simply the difference between the largest and smallest data values in the set. Then we have the deviation from the mean. So if you know the mean of a data set, then the deviation of each data value is going to be the data value minus the mean. And one problem with the with the range is that it is very easy to compute. It's just the largest minus the smallest data value, but because it is so easy to compute, it can be misleading. So the preferred measure of dispersion, the measure of dispersion preferred by statisticians is the standard deviation. So the way we do it, we first compute the mean of the data set, then find the deviation, square each deviation, add all the square deviations, and divide it by the number of data values minus 1. For example, if we have 10 data values, we divide this by 9. If we have 6 data values, we divide it by 5, and so on. So that is called the variance. The sum of the square deviations over the number of data values minus 1 is called the variance. And the square root of that, the square root of the variance, is the standard deviation. So we're going to do example 2 on page 755. We are going to find the range, the mean, and the standard deviation of the data set. So we're going to start with the range. And all we need is the largest and the smallest value. So we don't need to sort the data in order like we do with the median, but we're still going to do this. So we only have a few data values, so it's not very hard to sort the data in order. So the range is going to be the largest minus the smallest value. So the largest data value is 100, the smallest data value is 65. The range is 35. Next, the mean. We denote this with X bar. That's the sum of the data values over 8. We have 8 data values, so we're going to divide this by 8. Okay, so the sum of the data values is 680. Divided by 8, this is 85. So now that we know the mean, we can find the standard deviation. And one way to keep things organized is to make a table, in this case with 3 columns. If you have, if all the data values are different, you only need 3 columns, one with the data value, another one with the deviation, and the third column is going to be the square deviation. Okay, the values are 65, 65, we have 72, 77, 87, 89, 92, 98, and 100. The deviation is going to be the data value minus the mean. So we're going to subtract, the mean is 85, so we're going to subtract 85 from each data value. Okay, so 72 minus 85 is negative 13. 77 minus 85 is negative 8. 87 minus 85 is 2. 89 minus 85 is 4. 92 minus 85 is 7. 98 minus 85, it's 13. And 100 minus 85 is 15. Now, the reason to consider the square deviation is because the sum of the deviations itself is 0. So that's why we take the square deviation and then add them together and take the square root, divided by the number of data values and take the square root. So the third column is going to be the square deviation. That is, we are going to find the square of each deviation. Negative 20 times negative 20 is 400. Negative 13 times negative 13 is 169. Negative 8 times negative 8 is 64. 2 times 2 is 4. 4 squared is 16. 7 squared is 49. 13 squared is 169. And 15 squared is 225. So the sum of the square deviations is 1096. So we have this. We have the sum of the square deviations. With that, we can find the variance. Denote the variance with S squared. So this is the sum of square deviations over the number of data values minus 1. So the variance is approximately 12.51. And the standard deviation is the square root of the variance. So this is S. So that's the square root of the variance, which is the square root of 1096 over 7. This is approximately 12. Actually, what I did when I did this approximation, I gave you the variance. Yeah, I can write this down. So the variance itself, is approximately 156.57. And the square root of that is approximately 12.51. Okay, so that was the square deviation of a data set where all data values are different. So the next example is going to be the standard deviation of a frequency distribution. Okay, so I'm looking for the page to copy the, I will need 3 more columns for the standard deviations of a frequency distribution. So it doesn't give you, it doesn't tell you step by step like they like the way they did for the standard deviation. So I'll just copy the formula, and we're going to do the next example. But when we do the standard deviation of a frequency distribution, we need to consider the frequencies. So that is going to be the next example. Okay, so I'm trying to copy this. Yeah, this is taking a little bit longer to load, but that's what we're doing next. Okay, we're going to do number 19. Okay, so the following are the scores of 20 people who took a paramedics licensing test. Find the mean and standard deviation for this data. So now we have frequencies. That is, 7 people had 72. 1 person has 73, 3 people had 78, 6 people had 84, 2 people had 86, and 1 person had 93. So this is page 756. So now we need, we're going to make a table, but we need 6 columns because we're considering the frequencies. So we have the score that we're going to collect. We have the frequency. That we call F. Next, we have the product of the score and the frequency. Remember, we did, you did that to find the mean of a frequency distribution. So that's X times F. We find the deviation of each score from the mean. We square the deviation. And finally, we're going to find the product of the square deviation times the frequency. Okay, so that's going to be the last score. So that's square deviation times the frequency. Okay, the scores, we have the scores. We have the scores and the frequencies. And then we have the frequencies, so this information is given. So to find the mean of a frequency distribution, we need to add the product of the score and the frequency over the sum of the frequencies. So the sum of the frequencies is 20. That is 20 people took this paramedics test. The product, we're going to multiply the score by the frequency. So 7 times 72 is 504. 73 times 1 is 73. 78 times 3, it's 234. 6 times 84 is 504. 2 times 86 is 172. And 93 times 1 is 93. Okay, so the sum of the score times the frequencies is 1,580. So now we can find the mean. The mean is the sum of the score, the sum of the score times the frequency divided by the sum of the frequencies. So the mean is going to be 79. And we're ready for the next step. We are going to subtract each score from the mean, which is 79. So 72 minus 79 is -7. 73 minus 79 is -6. 78 minus 79 is -1. What we have? 84 minus 79 is 5. 86 minus 79 is 7. And 93 minus 79 is 14. Next step, we're going to square each deviation. So -7 times -7 is 49. -6 times -6 is 36. -1 times -1 is 1. 5 times 5 is 25. 7 times 7 is 49. And 14 times 14 is 196. And last step, we are going to multiply the square deviation and the frequency. Because when we find the standard deviation, we add 49 7 times. 36, then 1 plus 1 plus 1, 25 6 times, 49 twice, and 196 once. So 49 times 7 is 343. So we're multiplying this two. Then 36 times 1 is 36. 1 times 3 is 3. 25 times 6 is 150. 49 times 2 is 98. And 196 times 1 is 196. So add the square deviations, and we are already including the frequencies. This is 826. So we have the sum of the square deviations. Now we can find the variance. The variance is the sum of the square deviations over the total number of data values minus 1. So this 826 over 19. And the standard deviation is the square root of the variance. This is approximately 6.59. Thank you for listening.